Hello everyone, welcome back to EC Core. So in this video we will understand why Kirchhoff voltage law KVL is also known as energy conservation law. So without wasting any time we will go into the topic. So what does Kirchhoff voltage law states? My Kirchhoff voltage law, that is KVL, states that voltage drop in a circuit is equal to voltage rise, or simply you can say that V drop plus V rise is equal to 0. So this is what my Kirchhoff voltage law suggests, right? So similarly, if I am asking what does my energy conservation law state? So energy conservation law states that energy can neither be created nor destroyed. So in order to understand why Kirchhoff law KVL is known as energy conservation law, we will understand the, the process of how voltage is formed and so. So we know that KVL is based on voltages, right? Now we will understand how we are getting that derivation, right? Now first, let us say what is the fundamental unit of either electrical or electronic component, that is charge. So this charge is bipolar. That means it has positive and negative. Charge can be positive or charge can be negative. So this is the fundamental quantity of all electronic or electrical components. So here, now let us understand how we are getting voltage. So charge has two electrical effects of charge we are having here. So one electrical effect is known as separation of charge, and another is known as flow of charge. So I think you understood. Charge has two electrical effects, and one is this separation of charge and one is flow of charge. So let us say I am having a charge, two positive charges or anything. If I want to separate this, then I need to exert some force, right? And this, in order to expend this force, I need some energy. So what we can write from here, energy is expended to create force, right? So we will exert some force, and this force we will call it as voltage, V of T, volt. That is what you can write. This is voltage. If anyone is asking to define voltage, voltage is the force exerted to separate charge. So that is the definition of voltage. Now let us derive this one. So if I am saying what can my voltage equation be, if I am saying it is the force, V of T will be my dW1. So in order to separate some charge, I need to exert some force. So there is some work going on. So work done by time. So this, you can write this one as rate of change in energy with respect to time is known as voltage. Now I think you have understood this one. So from this, what we can write? Now this one we will use. Let us understand that energy conservation law with some simple example. So let us say this is one of my circuit where R1, R2, and R3 and R4 are my resistances, and the voltage across these resistances are V1, V2, V3, and V4. So if I am telling you to understand the voltage rise and voltage drop, right? So what would my equation be here? Sum of all voltages must be equal to 0, right? That means V1 plus V2 plus V3 plus V4 is equal to 0. We've said that voltage is equal to what? dW by dq, right? So here dW1 by dq, and here dW2 by dq plus dW3 by dq plus dW4 by dq. that is equal to 0, right? So if I am taking LCM, charge I am taking common. Now this will be dW1 plus dW2 plus dW3 plus dW4 is equal to 0. So this is my energy conservation formula. So that is why we will say KVL is same as energy conservation law, or similar, or you can say that KVL is also known as energy conservation law.